Okay, for number 4, it's asking us list the angles of each triangle in order from smallest to largest. So we have the three vertices. We have angle K, angle L, and angle M, and they want us to order it from smallest to largest. So what we need to look for, let's start with the smallest side. Obviously we have no angles, we don't know any of the angles right now, but the length of KL is that length because of the size of angle M. The more we open up this angle M, the larger LK would get. The more we shrunk down angle M, the smaller LK would get. So LK, the smallest side, goes with the smallest angle. So we'll start off by listing angle M, comma, okay, let's get rid of some markings. Okay, next we go to the medium size side, and we got side KM. Side KM is 4.3, so that's right in the middle. That goes with angle L. Angle L controls how long side KM is. So angle L would come next. Okay, and then last, obviously the only one that's left is going to be your angle K. Angle K is obviously across from the biggest side. So angle K. The second way to write this down in orange is angle M is less than angle L, which is also less than angle K. That tells us the order that those are in, from smallest to largest. Okay, number 5 is a little bit trickier. We have an x, a 3x, and 105 degrees, so we got a mix of knowing two sides and one angle. So you might look at this and say, okay, well, I know that 3x here is bigger than x, so I know that side ED has got to be bigger than side CE. That might help a little bit, but how does this 105 fit in? Well, if we look at 105, the degree is 105, that creates an obtuse angle. Okay, that creates an obtuse angle. Okay, you can only have one obtuse angle in a triangle. If there's only one obtuse angle, that's the greatest angle, which means the side across from it has to be the greatest side. So we're going to do this a little bit different. We know that E then is the biggest angle. We're going to write that last because it asks us to order from smallest to largest. So I know E is the biggest angle. So which one would be the medium size angle? Well, that would have to be the one across from the 3x because the 3x is the medium size side. So the angle across from that is angle C. Then obviously x is smaller than 3 times x, so the angle across from x, which would be angle D out here, would be your smallest angle. Okay, so ordered from smallest to largest should be DCE. You can also say D is less than angle C is less than angle E. Alright, for number 10, it asks us to order it from the shortest to the longest side. So the first few we did angles, now we're ordering from shortest to longest side. So it gives us two angles, 45 and 75, but we need to know this third angle to know how to order it. So we have to remember triangle sum theorem tells us that the three angles inside of a triangle add up to 180. So I'm going to call that other angle, angle X. Then to do the math, we're going to do 45 plus 75 plus x equals 180. And 45 plus 75 is 120, so I'm going to subtract 120 from both sides. And then I get x equals 60. Now I can replace my x with 60. I'll kind of erase out the mess in the middle. And now we know our three angles. So, from there, let's look. If we want to go shortest to longest, let's start with the smallest angle. The smallest angle we have is right here. So if I go across from that side, and I need to label the sides. Okay, we got them labeled there. So across from the 45 is side MN. So MN's smallest. Okay, so we're going to say is less than. Then we move on to the next smallest. We look up there and we look and we see ON would be the next smallest. And the reason ON would be the next smallest is this 60-degree angle. So ON is across from the middle size angle. Okay, and then that leaves MO at the end, and the reason MO is the largest is it is across from this angle, which is the greatest angle. That would be side MO. Alright, for number 16, you're going to have to look back to the triangle inequality theorem, and that tells you that two sides that add up have to be greater than the third. Any combination of two sides have to be greater than the third. So we're going to add these up in different ways and see if we get any of them that are less than, because they have to be greater than. So if I get one that's less than, then we can't have a triangle with sides with these given lengths. So let's add them up. We got 6 plus 3, and that equals 9, and 9 is greater than the other side, which is 2. Okay, so we're good there. The next one, let's do 3 plus 2, sorry about my bad handwriting, 3 plus 2 equals 5, and 5 is greater than 6. No, 5 is not greater than 6. 5 is smaller than 6. So right there we know we cannot have a side of 3 and 2 in a triangle with another side that is 6. Like I said again, the triangle inequality theorem says the sum of the lengths of two sides has to be greater than the length of the third. And this one, that 5 would be less than the 6. So because of that, the answer to this question would be no. Okay, let's try that one more time. So, can we have a triangle with sides with given lengths 11, 12, and 15? Well, let's start adding up the sides and make sure that any addition of two sides is greater than the third. So, I'm just going to go right into order this time. And we will go 11 plus 12. And that equals 23. So if I look back to my third side right there, 23 is greater than 15. We're good there. So let's do 11 plus 15. That would equal 26. And that is greater than 12. So 26 is greater than 12. We're good there. And then we'll do 15 plus 12. And that equals 27. 27 is greater than 11, so that works. We can have a triangle with these given side lengths. The answer would be yes. Alright, for number 2, it's asking to give the possible lengths of the third side. So I'm going to do a quick drawing just to help you visualize. We got this triangle here. One side is 8, one side is 12. What are the possibilities for the third side so that the three sides would go together and make a triangle? I'm going to show you a little shortcut that helps, and I'll show you why it works at the end. The shortcut is first to find the smallest the length could be. All you do is you take your two numbers here, this 12 and the 8, and you subtract them. 12 minus 8 is 4. So one of the sides, then that small side, x, or that side has to be greater than 4. That's what that's saying. To get the biggest the side could be, you just add the 8 and the 12. If you add the 8 and 12, you get 20. Okay? So x has to be less than 20. Okay? Remember, when we add up the sides, two sides cannot, or the two sides add up have to be greater than the third side. So we're going to check and see if this little shortcut worked. Okay, so we're going to do 8 plus 4.1. The reason I picked 4.1 because it says right here that x is x is greater than 4. Okay, 4.1 is greater than 4. If we do 4, it's going to be equal. So it's got to be greater 1. So I just said 4.1. And that equals 12.1. So check. 12.1 is greater than the third side, which would be the 12 right there. Alright, so we checked once. We got to do this 3 times. Next, we got 12 plus 4.1. So I did the side that's 12 long plus the 4.1 that I got from what I already figured out by doing 8 minus 12. And that equals 16.1. So check. Great. 16.1 is greater than any of the sides, so that works. And finally, 8 plus 12 would give me the 20. Okay, so 8 plus 12 would give me 20. Together they add up to being less than 20, because it says the third side has to be less than 20, and 20 is greater than any number that's less than 20. So all 3 sides check out. We're good, and that works. So remember, with these problems, if you just subtract the 2 numbers, you get the smallest it can be. If you add the 2 numbers, you get the greatest it can be, or the biggest it is. And that is it for the homework today.